So, this is the third time recording this. You don't need to know that, but sure, why not? We have equal length tube headers that are casted with a fill inside point inside of the manifold. And so by using the manifold fill solid area, it goes up, it goes over, it goes up, and it goes over, and it goes back up. Equal length tube headers. Now, that's really kind of not great, because if you don't know, the inside is a kind of like a right angle, and nobody really wants that. And so if you widen that area, and if you look here on the paper, you create these little indents, like slots that go in. But one side is going to have more of that skip along the boundary layer into that, create a turbulent vortex that then creates a pressure that then allows for like the in-between area of those slots to try and help curve it in to the direction, but it also has a push force because of that vortex that then also basically jets out. And then if you, on the inside part of that curve, as you can see, you create dimples there and little bumps and grooves, channels. So it's like you create dimples on the part right here towards the bottom, and that starts hugging it as it comes in. Then you create grooves, drop points, and then you're going to create these little bumps effectively alongside of the other part towards the top there, because this is a higher pressure, and this is now technically trying to keep things around, as those bumps create a counter-rotating, squeeze, if you will. So if you don't know, like if you have a blade that's at a particular angle and then you have another blade that's at another angle, as they go through, it creates a faster moving jet. And you also create pressure and resistance. But that pressure and resistance is actually good here, because as it curves in, and then you have the grooves that it slots into, and then you have a higher pressure above, and then that evens out with this much higher pressure below, then it sucks it up, and which actually creates a faster flow velocity, helping curve the exhaust gases with the tube length. You have to do it properly, you have to model the fluid, but once done appropriately, you gain an advantage to fluid flow through your tube, all in a much smaller package. And in fact, that fill area is now actually just an empty area. Okay, you don't need stuff there. In fact, you only need that little area to be not something that's allowed for you to go through. Okay, so it's an empty vessel. That means you make a tube for 4 tubes of equal length in the given size and parameters that you're looking for. There's a certain point where the size of the exhaust ports are much greater. And besides, you kind of want them to be a little thicker and bigger. Not thicker, but bigger in terms of the size of their tube than the exhaust port that it comes out of. That allows for it to exhaust into something that is less, voluminous. Not voluminous, less pressurized. And so as a result, you get a vacuum pressure, quotation marks. It's not really a vacuum pressure. It's just a lower pressure zone, which allows for it to go out easier, exhaust easier. Now, those little divots and channels. Now, channels are grooves, okay? So that's like a U. And then like the little dimples before help drag it into those grooves. Those grooves are a boundary layer, which means they end up acting like their own version of the dimples. But because they're kind of skipping along in the groove, that means that you have a very fast flow in the center and a very slow flow in the outside because of that boundary layer. And then those little bumps, which you only need a small amount. You need small. And so that's going to help curve it up and then flow them faster into what is a relatively slower moving air. That is lower pressure at the top because of that bump, and then it goes through, it creates a vortex, and then it creates a pressure where it's only able to escape one direction, and then that helps curve it already And then because of that vortex, you gain a pressure volume that vortex stays in there. And so then it slowly comes out. It leaks out. It's like a battery, like a flywheel battery that slowly leaks out. But you have another exhaust coming through. And that boundary layer that's on the side of the tube still skips into that slot. And now it's not all the amount of air. Okay, so like that creates its own version as it goes up, and some of it's curved in. So take your hands as it goes up. It's like some of it's going to fold in to this empty area, and then the others are just going to go up, and some of it is going to just stay straight. So some of it's going to curve, some of it's going to go curve the other way. But if you make it such that that curve the other way is curving inwards, and as that one curves that way, the other way, okay, and then you have the sideways motion, you gain a vortex advantage as it basically does a rotation that wants it to then come out of the tube. Think of the other way, you know. The mirror thing is annoying me on this camera. So it's like, as it curves that way, and then it's going to go vortex the other way. And so as it comes up, it vortexes counter-rotationally to the direction. And what that does is it basically has a boundary layer that's going to curve the vortex jets out with the direction of flow and travel that you want it to go, which helps with reduction of back pressure. And it helps with fluid flow rates. And it helps with a degree in measurability of reduction of exhaust gas pressure oscillation, resonant frequencies inside of the tube. So if you don't know, if it's not a perfectly smooth, completely straight line, then it tends to have a resonant frequency, as you've seen with two-stroke engines. They have these larger, and then it goes to a smaller, and that, as it comes in, creates a back pressure wave that comes back towards the two-stroke to try and help it get an advantage for its two-stroke nature as an engine. But if you don't know, any tube that curves is bang, 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 bang. So there's a lot of banging around. You don't want that banging. You want it to flow. You want it to flow real smooth. And so you reduce that oscillational pressure, which is back pressure, which is a good thing. And in fact, you use that oscillational reduction to basically maintain a version of these little flywheel vortexes, which aren't really flywheels, but then it's a mass that's spinning really fast, and so therefore it's coming out where you want it to as a bleed out, which is like a battery, a flywheel battery. But it's a fluid, and so blah 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 is what they'll probably go on about. It's not a flywheel battery, and I'm like, yeah, well, you know what? So it's not like a fucking solid object in the sense of whatever that is, but like it basically is, So like whatever, But effectively, that's all it's doing. It's like increasing the degree of speed and reduction of back pressure for the manifold. Now, also having way less, like you don't actually need it to weigh as much to gain the advantage of an equal length tube header can give you for such things like a turbo. Okay, turbos are really nice. It goes boom, 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 boom all the time. Every time it is giving it a pulse of energy. And so I can technically make this even better by shrinking it. I can shrink that small, because that's an empty space in the center. And I can remove that and shrink that down to it's a solid point, and then I widen the tubes that are equal length now, but in a given area. And it doesn't matter that that's hot metal. I don't need to cool it. As long as the metal is going to perform within the parameters of the given heat expectations it has, which it will most likely do with any steel or high temperature alloy aluminum or titanium. or even coated aluminum, which personally, that's what I'm a fan of, coated ceramic insulative aluminum, because I don't need to worry about anything. I can just on the inside of it, and I get rid of any of that, like I've got this excess carbon buildup, and I'm like, here's your exhaust manifold. Like, whatever, it's done, put it in some, thing, you get rid of the water, I suppose, over time, and use that carbon to sink it into the ground, you know what I mean? Just sink it into the ground, bury it, you know what I mean? Like give it a good 12 feet down or whatever. I don't really care. It's your freaking carbon. I don't need it. Maybe you need it for something. Point is, that helps out with our catalytic conversion processes, which is a really big benefit, because then it's like, oh, right, yeah, because it maintains its heat, and so then it maintains the heat up to the catalytic converter more easily, and then the carbon deposits are stuck in certain areas that are just easily washed out or scrubbed out, that kind of thing. And that helps the catalytic converter perform better because it's hotter, it has less of this carbon to change, and now we have like a better, exhaust that comes out as a result. And it flows better, which is not necessarily a bad thing. I mean, usually you want it to flow a little better. All you have to do is widen the ports where that is to match where the tube is, and then you're done. Like, it starts off small and it's a funnel to a larger part, and then that's what it is. So you're done, good to go. And I was like, oh yeah, no. It's pretty easy to cast this. It wouldn't be hard to cast that at all. And it's really the fact that it's high temperature aluminum, that really kind of fucking makes it annoying. Like, that's the only real problem, because it's like, then it's like, oh, well, actually I can just use regular, engine block aluminum that I spray with on the inside, or just coat it. I can use a slurry that I then activate using some heating or something else that then hardens the ceramic, and then it's good to go after that, which should work out well. And then equal length tube headers to a turbo. And I can change this geometric pattern around to make it better and more efficient for what it is. There's nothing saying I can't make a spin, a corkscrew, or a helix, or in this case, a double helix, because that's what it would be, a double helix. But the thing is, it's like, right, but then this makes it so that way it's going one direction. Technically speaking, I can still S-bend it the correct way, and it all goes out, again, the other side. One of the sides, or either side, if that's what you want, with two small little turbos, if that's what you're looking for. But for me, it's like, oh, it's all about the engine componentry and like, your engine bay and like everything for space that you have. So the reason why I was thinking about it is because it's like, this means I can make it such that the engine is, the engine bay that is more compact. Like, and I still have equal length tube headers to give to someone for a turbo, giving me better performance for my turbo. And that's why they use equal length tube headers. It sounds good too, you know what I mean? And then like I can still use a dump pipe from that off, from the intake for your compressor. So it still works. The reason why I was like, oh yeah, no, why don't they just have the exhaust coming out the rear? Why is it on like front wheel drive vehicles so they ever have it go, or these inline four side things, it's towards the front where the your radiator is? This is stupid. I hate this. And then like, because we need to bend it down and onto the side, and I'm like, equal length tube headers and a turbo. It goes off to the side. I have a turbo. Now it's in the rear. Now I don't need it near my very needing to cool my engine radiator. And the front and the rear are still capable of being, because it's an axle. A crankshaft is just an axle. So I don't see what the problem is shoving a thing in the front part of the axle versus the rear. Front, rear, what's the difference? It's an axle. An axle is an axle. Both sides are connection points. Why are we fucking fighting that? And that's all that is. And so it's like, turn it around, and now I've got like my front still good to go, and my exhaust, and it's like, right, but I don't actually even have to do that because the intake, no, I have to spin that around. Does it work? Is it symmetrical? My header, can I just spin the freaking stupid intake port, and then the exhaust is over there? And it's like, probably, I don't see why not. And it's like, fine, done. Just spin the freaking header around if it's symmetrical enough, and you grind the whatever the things, and then the intake's still in the front, and the exhaust is in the rear, and then I have like equal link tube exhaust manifold header thing that then goes into, and then to your turbo that then fires it off to the side. And then I have like an intake that I'm taking from all the way over here, and I'm like, I'm thinking, where's my axle? I need, and then I'm gonna just get a better axle, and I'm just gonna fucking stick that there. That way, it's further away from my hot exhaust manifold. And then I'm like, there's my intake over here off to the side, good to go. And then there's the thing that does the sucky in part with my valve stuff runes, and then it's going to go bang bang, and zoom is what I will achieve. I hope you followed along, you know. Anyways,